about all that. As usual, I want to make sure that you are on the same page. So we have little quizzes. Well, if not every class, but pretty much every class meeting. And I also have your up-to-date grades listed on the Blackboard, so you can always check how you're doing in this class by just logging into Blackboard. But please do that from computer, not from the cell phone, because I had a student who just showed me his cell phone that does not show any grade because cell phone does not really get all the information. I don't know why, for some reason. Maybe some cell phones do, but his cell phone did not. So that's why if you don't see the grade for this class on the Blackboard, you can either ask me or you can open this class from the laptop or desktop computer, and then you will be able to see it with no problems. So I noticed that some cell phones don't work, and that's why I was uh, keep asking you to get a laptop, some type of notebook. They're available for free in the college library. So do that. That's, I think, a very good idea to get a free device rented till the end of semester. And what we are going to do is we're going to refresh how this whole story and what it was about. And looks like we were looking at various graphs. And just to recap what we did, we had so-called library of functions, so that standard graph, such as a U-shaped curve, which is called parabola, where y is equal to x squared, is the one that we have been already encountering number of times, and that's the one that we will be using in the exercises. So what we were doing with these graphs, we were moving them up, down, and left and right. So to move the graph up, let's say graph of the same parabola, we add number, say 2, so the graph goes upwards. And I believe I asked you last time for the quiz, what happens if you have equation x squared plus 4. So what happens with this graph of library function parabola if you were to add number 4 to it? And the answer is the whole picture goes 4 units up. So it's going to be here someplace. It looks like that. And the answer was it moves up, because I asked you if it goes up or down. So the answer is it goes up. And if you by accident put down, or if you didn't take the quiz, say internet connection was no good, well, it's not a big deal. Just do the problem, any problem from this textbook, and send me your work by email at any time. So this way you will get this quiz mission fixed. Or if you didn't miss the quiz, just want to get some extra points towards your grade, well, just send me this as extra credit. But please make sure that you tell me what class you're in. So you tell that you're in 1033, MAT 1033. So I will find you right away, because I just got email from someone and I just have no idea what class this is from, because he didn't mention the class and he didn't write his last name. He just put first name. So it's just impossible to find. So please make sure you write the class, so he'll find you right away and you will get that extra credit points that you deserve. So that's to the exercises that move graphs up, or you can also move the graph down. So if you subtract 3, for example, the whole picture moves down by 3 units, the picture of that same exact parabola y is equal to x to the second. Besides bringing graphs up or down, you can also move them to the left and to the right. Like in the problem 38 that we already saw last time, the graph was moved to the left direction 4 units because of we subtracted, actually we added 4 inside the parentheses, and that's why the graph moved 4 units to the left. So that happened to the graph of parabola. And we also noticed that graphs of other functions, other library functions, behave analogously, such as, for example, a graph of cubic parabola. That's another popular graph that we will see every once in a while. So it's similar to parabola x squared, but now this is cube. And looks like analog of this is in exercise 34. And in exercise 34, this graph is actually shifted upwards by 4 places simply because they decided to add 4 to your x cube. So if you add that number 4 or any number to your function, then the graph of that whole thing goes up. So moving graphs up or down is one of the most popular procedures, as well as bringing those graphs to the left and to the right. Here in exercise 29, you can see analogous cubic parabola, but now it's moved over to the right direction simply because we have subtracted number 1 from x. So if you subtract 1 from your variable inside the parentheses, the graph moves to the right. And if you add 1, like in exercise number 30, then the graph moves to the left. So it's just like opposite when you have plus in the parentheses, then it goes to the left. And if you have a minus in the parentheses, the graph goes to the right. And looks like there was one more popular graph that also belongs to the so-called library of functions. That's an absolute value of x, which is like a check mark function. So they did also some work with that one. So I guess it's good to be familiar with these 3 major graphs. So I will leave those for you here on the page that you can see. And well, I guess the more you observe these graphs, the better you hopefully feel about graphing those. You will see them throughout math classes if you're going to take more math, like a college algebra or business calculus or anything related to calculus. You will see graphs of parabolas or absolute value functions. They are very, very popular. And the good thing is that all of the so-called transformations with their graphs are being, well, done pretty much in the same way without caring if it's a cubic parabola or absolute value function. So let's say if I try problem number 41 that says, how about if you take the equation y is equal to x minus 2 inside the absolute values. Let me graph that one first. So I'm going to be using this check mark function right now. And since it's 2 that we subtract, then it means we're going to have to move this graph 2 units to the right. So this will be our picture. And then the next step will be actually graphing what they want, such as y is absolute value of x minus 2 inside the absolute values, and then subtract 1. So what happens here? Well, looks like then I'm going to have to print this picture that I just produced here for you that has a 0.2 intersection with my x-axis 1 unit down, because 1 is subtracted from the whole thing. So now that check mark will be starting here lower than the x-axis, and again just the standard shape of it will give us the result. So you can put more than one of these transformations together. So I can do one more exercise just to make sure that we can better see that what happens with this, like in a problem number 43. Notice that now for a change we're using cubic parabola. The graph of it is right here, x cube. So in exercise number 43, I'm going to have to take the equation of absolute value, actually not absolute value, but x plus 1 in the parentheses cubed. So let me start out with this first. So x plus 1, since it's in the parentheses, I must bring my graph to the left or to the right, the graph of that cubic parabola. And it turns out that it's intersection with my x-axis will be brought 1 unit to the left. So this graph we have here for the cubic parabola is moved by 1 unit to the left, because again, plus 1 is inside of the parentheses. And then to finish up with this, to actually produce the graph they want, I'm going to need to subtract number 2, right? So when you subtract in 2, well, the whole picture should be brought downwards by 2 units. So that minus 1 now will go down to -2. And then the graph will look somehow like that. So the cubic parabola shifted down. So it looks like moving left, right, up, and down is really popular process. What else we can do with these pictures, with those graphs? And the answer is you can also put a minus sign out in front. So if you have negative in front of x squared, turns out the whole picture will reflect through your axis. So you just flip the graph. Let's say analogously will happen with all the others. So if you want to see what happens with the absolute values, if you put a minus in front, well, it's also going to reflect through the x-axis. So let me do exercise number 45 then. The problem that says put a negative in front of the absolute value. So graph this negative and then add 1 to the result. So in exercise number 45, I need to take a graph that I just produced above and then add 1. That means that we bring this check mark 1 unit upwards. So it's going to be something like that. So problem number 45 is here for us. So it looks like we just keep on graphing things in this little section and use so-called library graphs to produce the pictures we need. And the good thing of this book again is that you can see all the answers that you're supposed to get here right away. So I can see indeed that the graph we have is the same that I produced by moving the picture down because, oh, moving it up 1 unit because we're supposed to add the number. So it turns out that this is the last part of the story in chapter 2. We are done with it, which is great. Well, I guess the time is to move to chapter 3. And that chapter 3 is dealing with equations. Equations are quite different compared to the various simplifying equations. And what you can see here is a system of two equations. They call this as linear equations because those equations give us lines, right? We already encountered those cases when we dealing with lines. So they talking here about picturing those lines and then solving the system. Like in example 1 on this page, they give us two equations. They call it as a system because they put that big grouping symbol, which is called braces. Then they graph those two lines. And then from the picture, they able to find the point of intersection of those two lines. So they say that x is equal to 2 and y is equal to 1. And it turns out that when you decide to check this, if you replace your x with a 2 and your letter y with number 1, then what's going to happen? This equation will become the correct statement. So this solution 2 for x and 1 for y will check. And of course, it has to check in the second equation as well. So we can see this here. So 2 times 2 minus, instead of y, I put 1. It'd be 4, subtract 1. Indeed, it is 3, and it also checks. So the solutions check when I plug them in the equations. And that's the key idea of these little exercises in section 3.1. So all they want you to do is to be able to solve systems of equations. So let me try to actually see how they do problem like exercise number 15. And here they have a pair of lines graphed. I hope you see the graphs down below. The graph of the first one, x plus y is equal to 6, is the one here. That's my first picture. And then the other line is the second one, x minus y is equal to 2. That's the one in here, the second line. So looks like from the picture, they found a point that belongs to both of these lines. And this point is with coordinates 4 and 2. And notice that I can actually check this out. So I can see that 4 plus 2 is equal to 6. And indeed, when I add, instead of x, I use 4. Instead of y, I use 2. So that checks. As well as for the other, when I subtract 4 minus 2, and that's equal to number 2. And that's absolutely correct as well. So it turns out you can picture those lines and then find the intersection of those graphs. Sometimes it's not very convenient and not very straightforward to find the intersection of those lines, like say in the problem number 22, when you have these two equations, and when you graph both lines, well, you need to be very, very careful in terms of the scale to be able to see that indeed your point of intersection happens to be a pair, like they say, -3 for x and -3 for y, because it may be something fractional like -3.5 or some other fractional result, and that'd be very difficult to see exactly. And that's the reason why it's good to know that solution of the system is point of intersection of those graphs, but we prefer to actually solve these systems of equations some other way. So what be the other way to solve it? Well, let me show you an example 22, how we can actually find that system has solution -3 for x and -3 also for letter y. And this is a special method called elimination of your variable letters. And in order to use this method, what I do is I subtract my equations. So what I'm going to do is cancel the variable letter x. If you subtract from 2x down below, well, the x is going to disappear. Then if I keep going, I subtract from 3y, letter y, and this will become 2y's. And then notice now I need to be careful, because when I subtract, and this is negative, 2 minuses give us a plus. So actually, I'm going to get a negative number 6 when I subtract from -15 -9, because again, it'd be +9 when we subtract. So I've got the answer. Y is indeed equal to -3, just as they told us here right away. So this fact supports their answer they found graphically. So how to find the answer for x? Well, it turns out you can utilize any of these equations. So let's say if I take the second equation, 2x plus y, now instead of y, I put that -3, which is equal to negative number 9, and solve this for x, then I should be able to find what x is equal to. And when I start solving this by x, or start to isolate my letter x, I will get the answer, which is 2x equals to -6, and then x is equal to -3. So here's the other solution for this system. So people write it as a -3 for x and -3 instead of letter y. So what you can do is, of course, check this out like we already did. And I can actually do this. And then maybe I can ask you for the little quiz for today to also check and see if solution works. So what this means is you want to, instead of x and instead of y, in both equations to put those numbers, such as a -3 and a +3, and see if that is indeed equal to -15. And analogously, for the second equation, I have to put -3 again instead of x, and -3 instead of letter y. So I just put them in and wonder, are these two going to be correct statements or not really? Well, let's do some arithmetic. This is -6, right? And this is minus 9, minus 6, minus 9 is indeed minus 15. That one checks. For the second equation, it's a minus 6 and minus 3. So this is equal to negative 9. So that also going to check. So this is perfect. Solution checks. So how about if you try to tell me for a little quiz if in this system we have a solution that checks or doesn't. So what I give you is the pair x equal to 2 and y is equal to 1. So the question for the quiz is this a solution? Is x is indeed equal to 2 or 1? Is it y is equal to 1? So that's a yes or no question. Is this a solution? So just put solution or not. So tell me either yes or no. So how to tell? Well, check this out, just like we did already, like we did in the previous exercise, like we already did the number of times in the other problems. So that's our little quiz for today. All you need to say is either yes or no. And that's it. That's all we need for today. That's our little quiz. So please don't log out before you give me the answer. Is either yes or no. And once you answer that yes or no, well, you can enjoy the rest of the day. So we'll be done at this stage. Stop this to record. And again, just don't forget to put either yes or no in the chat.